All right, so hello and welcome. Here we are another day, or actually same day, not another day, just returning. So I thought about this question a little bit more, and not so much the question, but how I want to program it. Same day, not another day. How I want to program it, and there are a couple things I want to talk about. Okay, all right. So let's. Yeah, I fell asleep. Fell asleep before. Let's give me a moment here. I think I can do this. Okay. Something I want to test actually just before we begin. So this is the question that I'm interested in, and it's pretty simple, but the solution's a little bit involved. Oh, did I lose my code from before? Oh, I did. I cleared my cookies. I always clear my cookies. I don't like cookies on my browser. Well, that's awkward. I should have saved it locally. I didn't think to do that. I'll do that next time. Whoops. It's not that hard. I mean, I know that code by heart by now, so it's not that complicated. But anyway, given a 2D grid of zeros and ones, return the number of elements in the largest square subgrid that has ones on its border, or zero if such a subgrid doesn't exist in the grid. So there was a solution that I came up with that's efficient and relatively simple. Explained in the other video before I fell asleep. But before I get into that, actually, I want to look at the other question here. This one, alphabet board. Just look at my submission. And there's something I wanted to do differently because there's a cleaner way to do this, I believe. And I want to try it. Just submit this again to make sure it works. Okay, so that's fine. So what I want to do differently is this. And I thought about doing this before, but I was like, I don't think it'll work. You can do U and L, or U and U, yeah. And comment this out. Don't always have to use a for loop for things. This is going to be U, R and R, L and L. It's definitely a much cleaner way of doing this. Let me see. Oh, it works. It does work. I probably shouldn't have submitted. Oh, it works. Hey, there we go. That's much better. Yeah. This is what I was thinking about doing before, but I wasn't sure if it would work because I wasn't sure if you could build strings with 0 characters, but you can. Yeah, it's just an empty string, so no problem. Yeah, it's a very clean way of doing that. I like this a lot. Super clean. No if statements too. I don't like if statements. Prefer not to have if statements. Cool, very cool. Okay, that was just something I thought about the other day earlier. I was like, I don't know if that works. I think it does. I think you can make an empty string with 0 characters. You can't have negative characters. I think that'll give you some kind of runtime error. But try to construct a string with negative characters. But yeah, this constructor is very useful for strings in C++. I like it a lot. Definitely one of my more favorite kind of constructors. But anyway, okay. So back to this question. So the issue here is, I'll just rewrite the code that I had before, which is just int array of dp, m by n. M is grid size, n is grid 0 size. We're going to first initialize this with rows. dp of r, dp of r plus n, 0. And then the way this dp works is you have a double for loop. And also you initialize the first row and the first column. So first row is going to be, looks like this. And this is going to be dp of 0 is the first row. It's going to be grid of 0 C, which is again the first row, and it's going to be negated. So if I have a 1 there, then I want 0 here. If I have a 0 there, then I want 1, because I'm counting, looking for the largest square of zeros. That's what I'm doing here. This dp will give me that, the largest subsquare of zeros is what I want. I'm going to do something kind of fancy, kind of sophisticated. Not crazy sophisticated, but somewhat sophisticated. Shortly, I want to show what that looks like. I had an idea, and I think it works. I think you can do it. It's a little bit awkward, but I think that's what I want to do. So then we just say, now this is going to start at row 1, column 1. So we already did the first row and first column. So now we're going to do the rest using a DP. And this is just grid of RC equals 0. If it's not 0, then we put a 0 there. If it is 0, then we do this calculation. We want to get the minimum plus 1. It's going to be the minimum of 3 different values, dp of the top left position, dp of the left position, or the position above, and dp of the position to the right, or to the left, excuse me. Yeah, going top left to bottom right. We're looking at the left side, top left side, and above. Yeah, left, directly to the left, directly above, and up and to left, to the and to the and above. And add 1 to that. Yeah. This is one way of doing it. I think there may be a better way to write this line, but this is sufficient, I think. It's like reasonable. Okay. And actually, since this grid is either a 0 or a 1, you just do negate. You could do just bit flip. It's a 0, it becomes 1. If it's a 1, it becomes 0. I think that's how that works. If you say not 1 is 0 in C++, I think so. Pretty sure. But it might be better to write this explicitly. Maybe I should do that actually. Maybe I shouldn't use the bit flip. Anyway, so right. Okay, interesting. So now here's where things get more interesting, right? This is going to be direction value, or just array, direction array. We'll just say array. I don't know what to call this exactly. It's like another DP array, a different kind of DP. This is going to be sequence, we'll call it. Sequences of ones, consecutive sequences, C sequence, consecutive sequence. Not sure what to call that exactly, quite frankly. I don't want to use that many characters, but I also don't want to use that many characters, but I also don't want to use, actually, hold on. Just copy paste this in there. Don't want to use that many characters, but I also don't want to use that many but I also want it to be somewhat descriptive of what this does. So what this is going to do is kind of, I guess it's kind of sophisticated. It's actually going to use pointers. So we're going to have integer r, or yeah, r and c, right? And what I'm going to do, r and c, right? And what I'm going to do is create pointers. So standard pair int pointers. an array of these, pointer array, size 2, and that's going to be 2 pairs with these swapped R and C referenced, and then C and R. So I have a pointer array where I swap these addresses, right? Like I said, it's going to be a little bit more sophisticated than normal, but I think it's okay. I think it's all right. It's a little strange, but it should work. We're going to have increment operators, increment pair as well. Inc array also. So the idea is that I'm going to go left to right, top to bottom first. And I'm going to go rotate top to bottom, left to right, rotate again, right to left, top to bottom, rotate again, bottom up, left to right. I realize a bit confusing. So left to right is going to be increment by 1 in both sides. Left to right, top to bottom is increment 1. Switch now, top to bottom and left to right is also 1 and 1. Then switch one more time, right to left is -1, and right to left, top to bottom still is 1 again. And then switch one more time, bottom to top is -1, and I think it's always left to right, actually. Yeah, no, not always left to right. Left to right, top to bottom, swap, top to bottom, left to right, swap, or rotate, bottom to top, also left to right, still could be left to right, bottom to top, left to right, and then one more rotation is, actually that should be it. It's 1, 2, 3, right to left, top to bottom, and then finally bottom to top, left to right. Yeah. A little confusing. And finally there's going to be bounds for each of these. The boundaries themselves are going to be, really it should be tuples of 4 elements, I think. Tuple of 4 element tuples. Bounds, say B array. Similar kind of a thing. I don't know if this is worth all the effort. You know, maybe just write the code directly. I don't know. Maybe it's better just write it directly. I'm not so sure. Oh yeah, this is I should start using this form of declaring variables. I should do it that way. Anyway, what I want now is these are bound. So what I'm going to do is say the pointer pair. So it's not R and C. It's actually going to be. Oh, all right. Does this work? Basically, we have like A and B pointers, A and B. This is going to be so const auto. Oh no. Auto reference pointer is going to be pointer array. So all of this is actually defined up here. just defined once, and then made use of here inside this loop. And these are, as I said, it's going to be 0 to m. Left to right is the outer loop. No, left to right, top to bottom. It gets kind of reversed, right? So it's going to be the outer loop is actually the number of rows, and the inner loop is the number of columns. Rows, and then inner loop is columns. Then you've got right to left. The outer loop is yeah, it's like backwards. So right to left is going to be n to 0, right? Also the comparator too. I forgot. I have to also try to use the comparator, right comparator. And the comparator too. Yeah. That's kind of confusing. So I think less and greater or equal. Something like this. Greater or equal. Is greater underscore equal. This is definitely more effort, I think, than just doing it direct, all 4 of these directly, but I kind of just want something that's a little more, I don't know. Like I just don't want to have like, you know, a double for loop written 4 times. Just don't want to do it. Just don't want to. Anyway, so left to right, top to bottom, outer loop is going to be 0m, 0n. Then if we're going right to left, top to bottom, the outer loop is still 0m, but the inner loop is now n to 0. If we're going bottom up, left to right, the inner loop is actually going to be m to 0. And right, that's the bottom up part. And then left to right is going to go 0 to n. And then finally at the end, you've got one more row to, that's actually the, 1, 2, 3. That's actually that's the last one. That's the 4th one. Keep getting that confused. First one, left to right, top to bottom. Second one, top to bottom. These should be rotated. Top to bottom is rotated here. Top to bottom is 0 to n, 0 to m. Yeah. Top to bottom, 0 to m. Left to right, 0 to n. And then one more rotation. So that's the first iteration, rotate it. One more iteration, rotate it. Right to left, top to bottom. This is right to left. This is top to bottom. And then finally you have 1, 2, 3, right to left, top to bottom, and then, or bottom to, yeah, right to left, top to bottom. And then at the end, you have one more rotation where you're going bottom to top, which is this one, it's bottom to top. And then this is left to right. That's very confusing. That's really confusing. I don't know, it seems like it's probably kind of bugged, the buggy code, room for a lot of bugs if I do it this way. It's like very non-atypical kind of a thing. It's read backwards, so inner loop is here, it means we're going to go right to left, and then the other outer loop is then bottom to top. Yes, that's from the right. So this is from the left, from the top, from the right, and then from the bottom. Each of these directions. And the way it works is I have this pair of pointers, so R and C, where these A and B will be references, which I'm going to get the pointer to the pointer array, do pointer first and pointer second, basically destructure. And now when I increment A, right, so the way it works, it's going to be A plus equals, there's also another pair, which is going to be inc pair. Inc is inc array. So pointer array is going to be I. It's actually going to be I and 1. And then the inc array is going to be I directly. Which is this one, yeah. Inc array is just I. And then this is going to be inc first and inc second. And these are going to be actually dereferenced. Dereference these positions. Here we're going to have the comparator. So const auto comp is going to be comp array of I and 1, same thing. So it starts off 0, we're going to use less than. This is actually not correct. Comparators depend on this value, actually. Yeah, let's do it the other way around. So comp array less greater equal. Just comp inner and comp outer. And these depend on the increment, so they get paired with the increment. So this is going to be the increment first and the increment second. And we're going to take -1 or 1, and we're going to map that to 0 and 1. So I think you multiply by 2. No, divide by 2. Actually, you add 1, and then I think you add 1 and then divide by 2. Yeah. And use this in the comp array. Very straightforward kind of a thing. Not that straightforward, but simple enough. Just apply this function. Okay, something like this. So you got your inner and your outer, and that's what's actually going to happen inside here. It's going to be the comp inner, comp outer, and then comp inner. This is going to be A and the bounds. It's another element that I'm missing here. There's B1 and B2. So we have bounds const auto t equals B array of I. B1 start is standard get. So I mean we could destructure this. It might be better. Let's do outer start, outer end, or just O start, O end, and inner start, inner end, and then just decouple, what do they call it? Destructure, right? Destructure, right? So that'll give me the inner and outer boundaries. So it should be A is outer start and outer end, and then B is inner start and inner end. Okay, something like this. So something along these lines is what I want. This gives me code that has like, I want to call it like you know, multi-chromatic or something. I don't know, multiple colors. That's kind of what I'm thinking. It's got different. It basically has different directions it operates in. Does the same internal loop, but with different, I guess, different parts to it. And what's going to happen here is I'm going to reference grid of R and C inside, and this will be handled correctly. It'll reference the correct positions, even though, yeah, these pointers will change as this loop progresses. R and C will stay the same, which is the position here should start off at 0 initially. Yeah. And actually, I did there's a mistake here. So 0 to n, if it's a negative, if it's a reversed, it should be -1. It's a start. I don't know, the other way around. Starts here. Starts here if it's reversed. Yeah, basically, right, we set those values initially at R and C, so that's fine. Okay, and then we have this comparator. It's either a greater than or equal, so I end will be 0 in some cases, and then we increment by the increment values, which is you know, 1 or -1 depending on what we're doing. And then we also get the right comparator depending on it's 1 or -1 from this array. So this is just like an alternative to just hard coding all 4 directions, but I don't know. I mean, this is kind of like you have to get the information in there anyway for each direction. Like, it's not really that much better to do this. This is actually a lot more effort, quite frankly. It's a lot more effort. It's not as clear. I don't think it's good. I've done this before, but I don't like it. I just don't like it. Like, yeah, it satisfies that itch where it's like, yeah, we just don't want to have so many for loops, but it also is like, this is really complicated. This is like probably really hard to understand and debug as well, which is sort of a problem. Even if duplicated code is not great, but this is definitely more complicated. I don't know. I don't know if it's actually harder to debug. Like, that's the thing with duplicated code. Like, if something's duplicated 4 times, it's definitely more time consuming to debug it because everything you do takes 4 times longer, right? Whereas this is like upfront, a little bit of cost to like think it through, but once you've got it, it's not that hard to debug. Like, you just have to make sure that these are set correctly. So these just have to be set correctly, and then that the inner logic is correct too, which shouldn't actually, that part is abstracted, right? That can be anything basically. But now this R and C, these are going to be sort of managed by these pointers, and so now you can write this code and move through the grid in each direction, which is kind of what I wanted to do. So the idea is going to be there's a position. So there's a double loop, the way this works. What I want to do, I think I mentioned this before, is loop in whatever direction, loop until you see ones, right? So first thing to do is going to traverse. So we'll say int j is equal to the outer loop, which is b. Starts at I start, And so this gets a little bit confusing. Yeah, this is actually not that easy to work with. Okay. So there's a loop here. So we're gonna count. Let's do a count. Int count is 0. So we start at it's actually inside this loop, which is confusing. Yeah, so I probably should have written this first, what it looks like. Let me write it now. You can also see why I fell asleep after this, because I was doing a lot of thinking. I was really thinking about this. I was like, it's kind of involved. Let me write what it should look like normally first, so that way I have an idea. And then I can kind of shape it from there. So the idea is, for each row, we're gonna do something different, and it's gonna be count the sequence. So first start this at 0, and we're gonna say it's basically a while loop starting at so this has, we'll do it this way. Don't increment here, right? We'll do it in pieces. So for, we'll say I is C, right? The particular column, and I'm going to increment I until and while grid of the row and I while that is a 1, I'm going to increment I, and I'm also going to just increment I, just like this, right? And now my count is going to be I minus C plus 1, something like this. So set I to C, move left to right, move I over to some position, right? Then I want to write from I is C, count is greater than 0. I want to increment I, decrement count. And I want to write, not grid, but DP of row of I to count. This is what I want to do. This also, I think, is not guaranteed to be, I don't know if this is guaranteed, the sequence order. How does commas work in CP? Comma sequence, I don't know if that's guaranteed. The comma operator is what I want. It might be important. This might be not defined. Has the form any expression other than comma operator. In other words, comma operator's associativity is left to right. First, the left-hand operand is evaluated and its result value is discarded. Okay, then a sequence point takes place so that all of the side effects of LHS are completed. Then the right operand RHS evaluated, its result is returned by the comma operator as a non-L value. Okay. Gotcha. Okay. Notes. Type, maybe void, maybe an L value, but never in C. Comma operator may return a struct. Oh, so you can actually return the value at the end. That's kind of interesting. The right-hand side, right operand is returned. I didn't know that. That's kind of cool. It's a little weird, but okay. And then there's some notes. Not allowed in constant expressions, regardless of the top level or not. Oh, okay, cool. Top level is disallowed in array bounds. Oh my goodness, look at this. No, don't do that. No. No. It's not a constant expression. Oh no. Oh my goodness. That's a real headache. Don't do that. Please don't do that. Don't do that. Oh. Comma operator definitely makes things confusing, doesn't it? Oh boy. Don't. No. No. Oh man. Look at this. It'll return 5 here. Oh my goodness. Oh boy. Whoa. Anyway, alright. Whoa. Also look at this. Whoa. See that? What is going on here? Just notice this. 1, 2, 3, 4. 1, 2, 3, 4, 4 pointer references. Oh my goodness. Function calls. Oh yeah, function calls are could be pretty involved. Function to pointer conversions, yeah. Oh, function to pointer implicit conversion. Yeah, it's also confusing. Be 4 times, then call. Also okay. Convert to pointer, obtain the function. Wow. Yeah, this is called function to pointer implicit conversion. Well, okay, anyway, I was just curious if this was undefined or not. Behavior, undefined behavior, if I was trying to do it this way. Which one comes first matters a lot here. But yeah, that's basically what I want to do in the inner loop. Assuming this works correctly, which I have to debug it, I think. And then I want to modify this to work for this loop too. Oh no, there's more to it than that. I have to update. So yeah, this loop C, and then we're gonna update C to plus equals count. Count could be 0 too, by the way, or at least it's at least 1 if it's here. So yeah, that's that's a little confusing, right? This isn't correct, but this needs a little bit of work. But it's close. It's just like a basic. This is similar to the idea that I'm looking for. So while the grid has 1s at that spot, then I'm going to increment I, and this should be here then. I don't know if I could do it this way. Maybe I can. I don't know if this syntax works. I mean, maybe it does. Might. Yeah. So define this variable I, set it to C, increment I as long as you see 1s, and then set the count to be I minus C plus 1. I think I should just add here. So it should just be I minus C, actually. So if it's a 0, the count is 0, these don't do anything, this doesn't do anything, this increments to the next one. If it's a 1, right, then I is, it really is the same thing, it's just C equals I. If there's a 1 there, then it'll jump forward. And then there's a 0 there, it stops at 0. You can always skip the 0 here. Yeah, you don't ever have to actually, yeah, you can always do this. This makes it simple. So yeah, basically this is the idea. Very kind of straightforward what it does. Yeah, interesting. Kind of straightforward. And I just want to apply this inside here. Adapt and apply that to this. Hopefully that code is correct. So here, this int I is C. It's actually going to be, I think I need a pointer. Yeah, so this is this is going to get a little bit confusing, right? Because this is going to be R and C every time. This is also going to be R and C every time, right? But R and C are going to be managed by these pointers, quote unquote managed by these pointers. Managed is not the right word, but going to be handled, sort of the memory there is going to be handled underneath by these pointers. So this is going to be, probably should do actually a reference, and it's not going to be to C, which is, it's really B. It's B, so it's going to be just to B. A pointer, another pointer. I think, yes, so I need to save. Alternatively, I can just I need to save this position. Maybe that's what I need. So int previous position of B, right? And then dereference B. And then here, I'm going to actually increment B, right? So it actually moves B to a certain spot. Then the count is going to be the current position of B minus previous. One more issue here is this is I has to be less than n. And same thing here, I has to be less than n again, which I forgot about, which in this case is going to be B is less than n, quote unquote, which is basically this is the comp inner has to work, right? Comp inner has to be true. Just have to perform that check for comp inner. And okay. So if the check fails, that could be a problem, right? Yeah, this value is actually getting modified. I can't dereference. Oh no, I can dereference. That's fine. Yeah, that's okay. That's okay. I just can't. I can't array access with R or C. That's fine. Yeah, so this actually will be fine. So anyway, so comp inner, and yeah, it's the same thing here. So this just sets. This basically sets B back to previous. Set it back to the previous position, and just do the same thing again. Basically, same routine. I don't think I need the comparison here. Oh no, I don't need the comparison. No, they just use count. It's fine. Yeah, so this is the same. Yeah, this is a lot more complicated. Definitely way more complicated. And then B is just set back to, oh no, B is just stays where it is, actually. Yeah. B is just set to I. Whatever I was. Right, here. B just keeps that position. So it's a little bit more involved. But now R and C is always kind of what they're supposed to be. And then this still has the increment here, yeah, and the comparator. Yeah. That's basically how that works. That's adapting. I need to keep this, hold on to this, because this could be the wrong algorithm. I definitely need to debug this quite a bit, I'm sure. But yeah, this is like definitely really involved, this approach. I kind of wanted to try it and see how it goes. So now the question is, once I've done this, which I think I probably should have just had four of these double for loops. Really, this is like so much more complicated. Once I've done that, now I can run a run through with the DP as well as the, also this is not supposed to be DP, it's supposed to be C sequence, sorry, not DP. C sequence of I, yeah. Or just C sequence of 0, keep it simple. Yeah, that was the whole reason I had to do this, is because there's 4 of these things being set, so I have to do it 4 times. Once these C sequences are set, which is just consecutive sequences, right? When the consecutive sequences of 1s are set for each direction, the idea is I can then use that. I can go over my DP array, which is pretty straightforward actually. And I have just int best equals 0, and we could say for each row column, there is a DP value, DP of RC. So we'll just say const square size, DP of RC, and the this square size, this number is just the size of the squares, right? Yeah, it's not the area of the square, it's just the length of the square, size of the square. The square length, or square, just square size, or length, square length. What I want to do with that is I need an inbounds check, and I need, so there's four inbounds checks for four positions. It's going to be bottom right has to be inbounds and a 1, and the sequence going up has to be square length plus 1. So we'll say L is square length plus 1. It's actually plus 2, I think. It's plus 2. So we're going to say int position R, position C, or just say R. Yeah, we'll do RP and RC. Or PR and PC. Let's do PR and PC. Let's do it that way. PC. So position row, position column. This is going to be to the right and down, which is row plus 1 is down, and column is column plus 1 and down. Is going to be going up. So if inbounds check of PR is greater than 0 and PR is less than M, and PC is greater than 0 and PC is less than N. So inbounds check, and the sequence of ones, which is going to be C sequence of going up, which is right, down, left, up is the fourth one, of PR and PC, that has to be greater than or equal to L. Okay, if that's the case, then we can keep going. If not, then we continue. If that's not the case, continue. And then update PR and PC. Since we're going up, it's going to be subtract the square length. Going up is going to be subtracting the square length. I think I have to do minus L, actually. Let me think about that. So if you had, let's just say it was 1, square size 1, just 1, 0. Down to the right, there's a 1. The length is going to be 3 from that position. And let's say it is. So now where you're going to end up is you're going to add 1, 2. You're not going to subtract L. It's going to be L minus 1. Or alternatively, like square length plus 1. Yeah. Okay. That's going to be everything adds that much to that next position. It's all going to be the same kind of a thing. So 1, 1, 2, 3, 4. The second thing is going to be moving to the left PC. And this is going to be, now we're checking the right side, which is, we said right, down, left. This is going to be the left side. 0, 1, 2, left side. Left side. Then we're checking, now that we're on the left side, we're going to check down, which is 1, I think, and then it should go in a sequence. 1, 2. This one is adding, right? PC subtract PC. So we have PR PC here. Could we go up? PRPC, subtract from PR, and then we go left, we subtract from C, PC, and then here we're going to add back to PR and PC. And this one is going to be down is 0, 1, and then left to right is 0. Yeah, so that's why, and if all of those things are true, right, if all those things work out, then this should actually bring me back to the original position. We don't actually need this line of code. That's not necessary. We just need to go check, 1 check, 2 check, 3 checks, right? If all those checks work out, it'll be 4 checks total. 1, 2, 3, 4. If those are all true, then the best size is going to be. Now, what are they looking for? They want the number of elements in the largest square subgrid that has 1 on its border. Okay, 0 of such a subgrid doesn't exist in the grid. Okay. That's just the square size. I think it's square length squared. Yeah. It's just the square length squared. So something like this. Now, does it have any 1s on its border or only 1s on its border? Because that's what I'm going for. Yeah, so this is a little bit involved, to say the least. Quite a bit of code, quite a bit of debugging, a lot of kind of sophisticated things going on here. This is not too complicated, but this is very complicated what's going on here. I'll say it's sophisticated. I want to say it's not that sophisticated, but it's like, it's actually kind of involved. It's a little bit involved. Gotta be kind of clever to get that to work correctly. Okay. What is going on here? This is weird. Why does this give me 1s here? I don't think this will get, I don't know what my answer is going to get for this one. I know it should do it correctly here, but this one, also this is wrong. Or I'm sorry, not wrong. It's the subgrid, excuse me, including the 1s is the, okay, never mind. So including the 1s is fine. All right. So it's actually this one. It's L squared. It is this one. I wasn't sure. Okay. So L squared. So I don't know if I'm going to get a 1 when I do this. If you just get a 1 alone, that's a 1 also. I'm not sure how I'm going to handle that exactly. We'll come back to that in a minute. So let me try, just see what this does. First off, let's check it doesn't crash. That's like the, you write this much code and you're using pointers, it's like the first thing you want to check is it doesn't crash. Okay, compile error. All right, not what I wanted. Indirection requires pointer operand. Invalid. What is this one? Where's the line? Okay. Well, let's just check to see if it's this piece of code. See if everything else is correct. It's probably this piece of code here. No, something else is wrong. What else is wrong? Oh, it's this one. Okay. Oh, this is not DP. That's my mistake. Small errors here and there. It's a lot of stuff to think about. It's a lot of code. It's just like a lot of things. It's very easy to make mistakes. Array of auto. I guess I can't do that. Okay. All right. That's pretty funny. Boolean int. I think it's probably what I want. I think that works. That should be fine, right? That's pretty funny. Okay. Can't just have an array of auto as much as I would like to do it there. That would be perfect. I could do declare type maybe, that would work. I might do it. Wrong answer. Oh, it actually compiled it ran though. That's amazing. I was expecting this to like crash or something. Let's try that actually. That would be a good idea. Declare type. What is this? Does it work? No. I don't know. I don't use declare type very much. TLE, whoa. Okay, well, yeah, I don't think that works. I think I gotta make it a function, otherwise it's gonna it's gonna just turn my greater or equal into something else. I don't know. I don't know what happened, but probably should just keep this as it is. Okay, so that's interesting. All right, let's print. How far do I get here? I think this is never reached, right? So let's do. Let's see if I ever get past the first one. Called 770. Probably not. Probably just never get past the first check. All right. Make this 820. 870, excuse me. And 920. Yeah, this definitely is going to require quite a bit of debugging, I'm sure. I am sure. Okay. Never called any of those. Of course. What happened? Okay. Interesting. So if it's not this, then we continue. Gulp. What is 740? I'm sure this gets called. It's just check, or just just print it. It's fine. I'm sure this crashes at some point too. Let's do it this way. Let's do it this way. All right. I like that. That's good. Oh, I keep it's a bad habit. That's a habit. Totally not even thinking about that. When you're programming, you do a lot of stuff, and it's very easy to just forget that you changed something, changed your habits. Oops. Okay. Yes. I want new line characters, not standard end line, because it flushes the buffer and makes things slower. Unnecessarily flushes the buffer when I don't need to and makes things slower. Something like that. I forget exactly what. Someone explained that briefly, but what is going on here? Why is this wrong now? Oh. Yeah, that'll do it. Someone explained that, but I don't really look into detail as to like why exactly it's not good. I think it's the buffer doesn't need to get flushed that frequently. I think is the issue. These are all just zeros, right? Okay. Okay. Not always in bounds, and it's just zeros every time. All right. That's a bit awkward. Okay. Interesting. Of course. Of course. So yeah, this is B either is corresponds to R or C. Could be one or the other. And count the difference between the previous value and the current value. If it's going in the other direction, this will be a negative number. That's probably what's happening. I didn't think about that. Oh, okay. Let's do it this way, actually. This is better. Yeah. That'll work. Should work, I think. Should work. Something like that. Something like that. Let's try it. That's a little bit easier to handle. Okay. Still zeros though. Okay. I don't know what's happening. Let's do this piece of code. Run this and see what I get. Still get zeros. What is going on? What's PR and PC? Okay. Alrighty. Okay. One and one. Alright. That's exactly zero. Okay. Sure, I guess. Okay. 1 and 2. 0, 1. Row, column, what is it? Also, I don't need to perform this check unless it'll actually be a larger amount. I could also optimize this slightly, but it doesn't. I don't think it matters that much. It's like it'll probably has to have at least a has to be a 0. Yeah, I could just grid of RC. You could do that too. If not, skip all the ones. Should only really happen when this is 0. Okay, very good. So 2, 2. 0, 1, and then 0, yeah, 0, 1, and 0, 1, right? So that's where R and C is, and then here 2, 2. So we have a 0 there. All right. What happened? Why did my it's also debug. Why did my algorithm fail? I just want to print this. Oh, I get a lot of what do you call that? Get a lot of nuisance, not too many, but I get some nuisance calls. I've been picking up nuisance calls lately, and asking who's calling, but they don't answer me. They just hang up. They're like afraid or something. I don't know. Scared. Cowards. I've often wondered if I could like find people like who call me, track them down. Probably could. I know some stuff. I know some things. But I don't know if I have the time for that. It's probably more so the issue. I don't have the time to go find people, hunt them down. Hunt them down. What do you call my phone for? Yeah. Anyway. Oh yeah, this worked, by the way. Did it work? Yeah, this compiled. So yeah, you can run statements like this as part of the initial part of the for loop. But I'm looking for I just want to print this C sequence. And get a new space and then new line. Yeah, it's fine. Something like this. See what this does. Try to get a printout of what my results look like. Yeah. Okay. So that's from left to right. That's actually correct. That's what it's supposed to be. Oh. Oh. It worked. What? Does the other one work? Kidding. No. Okay. Okay, that's kind of what I expected. For some reason, this just didn't work. I don't know why though. The greater than less than might be the problem. It's got to be first one is less than, 0 is less than. So if the increment is positive, oh, that's why. Yeah, that's the issue. It's the other way around. It's the increment is negative. This should give me a 1. Oh, I could just flip this. Just do that too. It works. I think. Oh, okay. Okay. All right, that was more what I was expecting before. I was expecting some kind of runtime error. Oh, that's funny. Or you know what I could do? I could flip these. That's easier, actually, than bit flipping. Right. No. Well, less should be. I'm mapping -1 and 1 to 0. Yeah, actually, we should just flip it here. Should flip it here. That's easier. Anyway, so yeah, I mean, it definitely gives me a runtime error. Okay, I was expecting that before. I was surprised I didn't get that before. It's like, what is going on? Okay. So the question is, what is the problem exactly? How far does it get before it crashes? Start with that. Start with that. Okay. Oh. Typo. Okay, 0, 1, 2. Okay, gets pretty far before it crashes. Gets to the third one is actually the one it crashes on. Well, that's interesting. The third one is this one. So the inner loop is, so this is going to be bottom to top, right? Starting from m-1. It's interesting that this doesn't crash, but this one does. Oh, no, actually it crashes on this one. I'm sorry. Take that back. It did crash here. That's right, it did crash here. 0 got through, 1 got through, 2 is actually right to left is where it crashed. It didn't get to 3, so it would have crashed on 3 too. Yeah, okay, so it's probably this is what's crashing. It's got to be this. It starts at the inner loop starts at n-1 and increments to 0, 1, 2, and increments to, oh, that's exactly, that's the problem. There it is. This is the outer loop, not the inner loop, right? Yeah, that's really confusing. The increment for the outer loop is actually reversed. These should be reversed, is really the issue. There should be 1, -1, and the same thing here. That is very confusing. Very easy mistake to make. Yeah, there we go. Okay. Oh, look at that. That works. And look at this. We get the right output here. Okay, that's cool. Sweet. Beautiful. Okay, very good. I might have something to do with it. So let's do for each I. It's pretty amazing that it worked. Pretty amazing. Pretty amazing. All right. Let's see now. What do I get for my outputs here? Okay. Oh no, it's all the same thing. It didn't rotate. What is going on? Oh, no. It's not the same thing. Excuse me. That's my mistake. I forgot. So I'm going so quickly, I'm forgetting details here. Small bits and pieces here and there. All right. So this one's correct. This one, top to bottom. This one's wrong, and this one's wrong. These are both wrong. Let's go bottom up. Bottom up. All right. So that's why I'm getting zeros. I should be getting this should be 3, 2, 1 on the right side. 3, 2, 1 on the right side. This should be 1 on the right side. 3, 2, 1 on the right side here. And same thing here. This should be going up 3, 2, 1, 1, 3, 2, 1, and this should be 1. Okay. That's a little weird. Okay, this is the inner loop. We're going so left, down, or excuse me, to the right, down, and to the left. Going to the left is going to be right to left on the inner loop, and top to bottom on the outer loop. So this inner loop, we're going to do n-1 and 0. It's going to be I is 3, so we're going to have a greater than here. Oh yeah, the increment is greater than when it's negative, so -1 gives me, oh shoot, I mixed these up, inner and outer. This is first and second. This is very confusing, huh? The second value is the inner. Whoops. Oh, that's very confusing. Yeah, the outer is the first one, and the inner is the second one. Yes, inner, outer, right? Oh my goodness. Or outer, inner. Yeah, outer, inner, right? That might have something to do with it. I'm not using the right comparators here. I'm afraid that's, oh, there we go. Hey, it worked. Okay, sweet. Look at that, beautiful, gorgeous, gorgeous. Now it's working. Okay, very good. Yeah, that's what I was saying before. Like, this is kind of wonky code. Like, I don't think it's good. I don't think it's good. I think you're better off just writing the loops exactly as they are. Basically, just 4 of these things. Just copy paste it and modify all the variables and things. Just hard code it. This is like a kind of hard coding. It's just, this obviously can be modified to add, well, you can't really add much more. I mean, there's only 4 directions you can consider. Do you hear that? My dogs howl. They're huskies. They're like part wolf, sort of, and the relation, they're related genetically to wolves, and so when they hear the sirens, the howl. You can hear it. I could hear it. I don't know if you could hear it. Assuming you could hear it. Anyway, so okay, great. Things are working out. Get the wrong answer for this second case though, because it's a kind of a I get the wrong answer for the second case because it's kind of a special case, quite frankly. I'm gonna leave that commented out because I don't really need that. Basically, this case is just if there's a 1 present, then it'll be at least 1. And if there's no 1 present, then it starts off at 0. So it's just, you can kind of put that anywhere in here too. We're just gonna say best equals standard max of itself and 1. Just do that if there's a 1 there. Yeah. So if you see a 1 anywhere, it'll upgrade that to a 1. I don't really know why they defined it that way, but they seem to have defined it that if there's just a 1 there anywhere, then it just gets a 1. And so now if I do something like the following, ready for this? Okay, I need a square of like 4. So it's going to be 1, 2, 3, 4, 0 here with a 1 here, 0 again with a 1 here, and then this should be all 1s at the bottom. 1, 2, 3, 4. This will be 2 by 2. Okay. And then this could have whatever in it. This could be zeros or whatever. Doesn't matter what's on the bottom. Something like this. Let's have one such. Okay, so I think this is correct. I think this is it. Yeah, I think that's the rule. It's just if there's a 1 so I can just have this extra while I'm looping through here. Just check. If I see at least 1, 1, then upgrade this to a 1, and everything else is going to be more than that. I don't really know why they define it that way. Just like if you see a 1, that's what that's just what they say it is. I don't know. That's just what the output is. So I'm gonna go for it. I think. I want to try. Let me try another case that has 2 of these in here. I want to put a 3 by 3 underneath. So I need like 7. 1, 2, 3, 4, 5. 1, 2, 3 by 3 is 3 by 3 is fine. It looks like the following. So 1's here. We'll put a 1, a 0, and a 1, and then put a 0, a 1, and a 1, and a 0. We put another 1 here too. How about this one? This it uses a significant amount of memory, this approach, but it should be, I think, efficient, and I think it's also correct. Yeah, so it ignores the second one, and then if I modify this one again, so we can modify this one again, and I just throw a 1 somewhere in here in the middle, right? It should drop down a 9. Solution. So there could be more. Oh no. Ooh. 16. Whoa. Whoa. What do you mean? Hold on. Oh no. Oh, it doesn't have to have all the zeros on the inside. Oh. Oh no. I misunderstood the question. That's why they're okay. Okay, I'm gonna go lay down. Oh, I think the solution I came up with is actually for a harder question. And I did it. Can be adapted to what they want, but oh, that's disappointing. Oh no. Gee. Oh boy. Say it ain't so. Oh my goodness, that's a little awkward, huh? By the way, if I was doing this during an interview, I definitely would not take this much time, and I wouldn't take this approach either. Oh no, it didn't say that. It didn't say it has to be zeros on the inside. I just assumed it. Oh no. Well, that's really awkward, huh? Oh, it's a totally different question. It's that is a totally different question. Oh no. Oh, you gotta be kidding me. No. Excuse me. Well, now that I've coded this, I could use it, but that's awkward, huh? Well, that's awkward. Jeez. Okay. Okay. Yeah, I mean, it's like the same idea, same sequence, but instead of, excuse me, I don't actually know. No, it's not the same. No. Oh no. Oh, what a mess. Uh-oh. 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 No, yeah, you can still use the same approach, I think. I think it still works. It's just it's quite a I don't know. I missed it. I don't know what to say. It's just excuse me, totally different question. Totally different question I was trying to solve there. Oh my goodness. No. Whoops. It's a good thing I tested it. It's a good thing I tested this. It's like, come on. That's very awkward. Right. Oh my goodness. Interesting. Very interesting. So about that. Gee. Oh my goodness. Excuse me. So yeah, I could use the same approach, but what I would do now is just basically start with the first element instead of starting with instead of starting with what's that called? It's like really funny. Instead of starting with instead of looking at the DP amount, the largest zero submatrix, instead of looking at the largest zero submatrix and going from there, I could just start with the largest. If I just go left to right, top to bottom, I could just start with the largest left to right sequence. Because as I move, it'll get smaller. Yeah, I think that's fine. Yeah, because the square is going to be symmetric, right? So if there's a square of size 5, it doesn't matter if I start at that point looking for it and go clockwise, or if I start at the end of that point. If I start from 5 to the right and go counterclockwise, right? Doesn't make a difference. It's there. That's what it's going to be. And then if I look for, oh no, I can't do it that way. No, that won't work. Oh shoot. No, because there could be a smaller one, but I'll miss it if I only look for 5. Shoot. Maybe I just have to do both directions then. Left to right and right to left. Yeah, I think I have to do right to left also. Left to right clockwise and right to left counterclockwise. Well, that sucks. Well, that sucks. There's probably a better way to do this, quite frankly. Jeez. Think this through here. No, that doesn't work either. Actually, no, I don't think it can be adapted the way I think it. I want to adapt it, but I don't think it can be adapted that way. Gee. I actually don't know. I don't think what I wrote can be adapted to that. This solution, because you could have like, well, yeah, no, I'll just say no. I don't think it works the way that I'd like it to. Maybe I can adapt it a little bit. And maybe I don't need to do so much extra work too. I could just first pass just writes in the left to right sequences, the longest left to right sequences. The second pass then will take the next sequence down. I'm sure there's a way to do this that doesn't require as much work, but I'm thinking, how can I use this information that I already have here? The code that generates this information already. You get your left to right values, right? Well, really, well, I guess what I'm trying to say is that I want to check the corners. So I want to have each corner has a minimum of the left to right distance and the top to bottom. Or I guess in the top left corner, it'd be left to right and then top to bottom, right? Whatever square that I have is bounded by those values. And then, no, it doesn't really work. No. No. Gee. This is a good question. I don't know. Don't know. After all that, solve the wrong question. Solve the wrong problem. No kidding. I thought that was kind of hard for a medium question. Thought that was maybe a bit much. Apparently this one's a little bit easier. I don't see it though. Gee, I don't know. Huh. Good binary search. That works too. Yeah, that's a pretty simple way of doing it. That's probably the easiest way to do it, just a simple binary search over the. So at each iteration, you're going to just look at every top left corner and then check to see if that particular square size exists, right? It's just a 4 by x, whatever x is whatever the size I'm looking for, or the length of square, let's say the length, whatever the length is. So the length could be at most, I think, 100. And it's just 4 times x is the perimeter. You just go left to right to check to see if you find all ones with that amount. So it's 4 times x times O of m times n, and then x is at most m times n, I think. No, excuse me, it's at most m or n, whatever you want to call it. Yes, it's at most m, and then this is performed a logarithmic number of times. Log of n. So m, let's just say m and n are equal, right? Just keep, in the worst case, it could be that is true. So it's just like O of n cubed log n, 100 cubed. 100 cubed is kind of a lot though, actually. Is that right? Is that correct? It would perform this check a logarithmic number of times. But each check is takes a linear amount of time. You can optimize that linear amount of time by just by actually running what I already have. Yeah, gathering that information of the longest sequence in each direction. That only takes a quadratic amount of time, and then you can end up with a quadratic times log n times algorithm, which is efficient. Yeah, because then you can do the rotational checks that I described before. As long as you just need the size of the box that you're looking for to perform those checks. And the previous solution automatically gave you the size of the box. So yeah, you can adapt this. You just use a binary search, basically. Okay, saved. Saved it. Is there a better way to do this? There might be. I'm sure there's a better way to do this. There's probably a way to do it that's linear in the number of cells, but I just don't know it offhand. And I don't really want to spend the time to think about it, quite frankly. Kind of just want to move on to the next question here. Maybe I'll look at the solution. The solution will probably have it. Yeah, if I think about it for a while, I'm sure I could find it. Excuse me. I don't think this question is intended to be that difficult. All right, we'll do it that way. Binary search. Binary search it is. It's pretty funny. We don't need any of this. Excuse me, and keep this code, which is fun. Now we're going to say, is there A and B? A and B, I think, are just here, right? Yeah. So int A, or yeah, A is 0, B is, we'll do them the min of these two, m and n. And then we're going to say for the following int, or let's do a while, and we'll have best starts off at 0. A is less than or equal to b. If this condition is true, then we're going to increment a or m. Mid, we'll say not m. Mid is going to be b a plus b minus a divided by 2. And then we're going to say if something something, then we're going to say a is mid plus 1, or b is mid minus 1, and set best equal to a. So if it's true, we want to go to the right, which means we increment mid plus 1. If it's not true, then we don't update the best value, and then we go to something smaller to the left of b. Yeah. So then the if statement here is going to be inside this routine. So we look through each row and column. If we see grid of RC, I don't know if I actually need to do it this way. I'm not going to do that. I don't think I need that anymore. So the square length is not dp of r. It's actually going to be mid now. And L is just mid. So just L is mid. So forget L, just use mid. Wherever we see L, just use mid. And mid squared, and this is going to be mid minus 1. Okay. Okay. And PRPC is just R and C. Just want to use new variables for that. I guess still do that. Yeah, and just to rotate it all the way through. And that's basically it. Goes to the right, that mid amount, down that mid amount, left that mid amount, and up, back up that mid amount. That'll take me back. And so that'll give me a binary search, and I'll say check is what I'm looking for. Bool check is initially false. So all these will continue, and instead of setting best, we set check equals true. Right. So if I get all the way through, then I'll set the check to true. If the check is true, then we set best to A, and we'll say best length. Not best anymore, best length. And this is going to be best length squared. Okay. All right, if there's a 1, then all of these checks should pass because mid minus 1 is 0. And so it just passes all the way through if there's a 1. Okay, something like this. This should give me better runtime than I had before. Not a better runtime than I had before, but it should give me like O(n) squared log n time 4. 0, 0, 0, 0, 4, 25. What is going on? Okay, this is definitely wrong. I don't know what's wrong exactly though. Okay. I think this code's fine. I think it's this. Something's wrong here. So we can't get something larger than the smaller of the two, right? Because we're looking for a square and a grid. This should give me a plus b over 2. Check starts off at false. Each row and column. I don't need to check this anymore. This is always going to be yeah, this really is just actually this could just be if actually you could just do a loop. Oh no, I do need each one actually. Okay, never mind. Yeah, okay. Just the conditions. Two, 1, 0. Okay. So it's going to be, this is the first one, second one. I think I butchered this thing too much. Oh, this one. So first check, we don't move anything. Second, then we move up. Then we're going to move to the left. Then we're going to move down. Then we're going to move to the right, which we actually don't need to check this one. Don't need to do that. Yeah, so 3 moves. Okay, a little more involved. Okay. A little bit cleaned up, I guess. Try this. Simplifying the code to just make it easier to understand what's happening. Oh, runtime error now. Okay. Oh, I do need the runtime. I do need the bounce checks too. Okay. Maybe I'll go back then. Yeah, I do need those bounce checks. Take it back. I had it right the first time around. I forgot that I move around the I'm actually moving around the grid. Totally forgot about that. Yeah, it's fine. Just keep those bounce checks then. Okay. So yeah, if I get all the way through, I just set check to true. And leave it at that. I could do or equals, but it doesn't really matter, right? It's like it's idempotent. So this is just wrong. I get 4 somehow. How did that happen? So I should get 3, 3, 3, and 3, right? They should give me 3, not if it's true. Huh. Okay. How are we doing? Hour and almost 2 hours. 0323. And it stops at 2. Oh. I can't use a binary search. I keep thinking I could use binary search. I can't. That's the second problem I did that. This is wrong. This does not work. False. False. Actually wrong. No. Can't just use binary search for everything. It's not true. Oh my goodness. Go lay down again. It's not true. You can't just use binary search for everything, man. It doesn't work like that. Oh, that's very funny. Jeez. Oh my goodness. Gosh. Sometimes I just think you can and you can't. It doesn't work like that. Incorrect. Incorrect. Again, incorrect. I did that before too. Same thing. So some questions, when you're searching for a certain number, if it exists, it does not imply that either the numbers that are larger than that also exist with that condition, or numbers smaller than that also exist with that condition. That's required for a binary search. It has to be everything is all zeros on one side and all ones on the other side, so to speak, where the zeros and ones are the conditions that are pass or fail. It's the condition that passes or fails. Yeah, so if you see something that's of size 2, which I don't know why my algorithm even saw something of size 2. I don't know how that happened, but that probably shouldn't have happened. But anyway, somehow that happened. Yeah, if you see something that is of size 2, it does not imply that, or excuse me, if you fail on something size 2, I think that's what happened. I think it failed on something size 2. I don't know. I don't know what happened there. I don't know. I think I actually, what did I do? What did I do here? Hold on. Hold on. What is going on? Wait a second. Wait a second. Whoa, whoa, whoa. Whoa. Oh. Yeah, okay, that's wrong. I mean, I coded it wrong too on top of it, but yeah, I was gonna say, I was not expecting to see 4 at all. The reason for that is it's not supposed to be A, it's supposed to be mid. I don't know why I did A. That was wrong. That was the mistake. One of the mistakes, but still, it's still wrong. It's just, it should have been a 1, not a 4. There's just some very confusing results. Yeah, so the issue is that I basically would need to search every possible. I mean, you could just search every possibility for this too, and that also works. It technically would be cubic in terms of n. It would pass the test cases. You could just go back to front, and that works too. It's just a little awkward. For L, yeah. I could just finish the problem here and just do it this way. Could also just have. Could also do it this way. L is greater than 0. and just say, don't even binary search and just do it just a straightforward search. That actually would be efficient enough. That actually would be fine. Yeah. This is a really complicated solution, but it'll work. It's just awkward, really awkward. Okay, and then check is true. We just say if. Here we would return L, starting from the largest L value and going down from there. I don't need any of that. We can triple for loop. I mean, yeah, this would be correct. It's a little slower, I think. It's triple for loop now. Quadruple cubic time now. L now. I think that's all I need to do. That'll also work. It's definitely not. Oh, okay. I guess it doesn't work. Oh. Excuse me. L squared. It'll definitely work. It's just it's cubic time now in terms of and should be fast enough actually. I think in most cases. Excuse me. It's just I'm gonna go for it actually. I think it works. Just a really awkward. I think there could be some kind of error though. You know, I'm gonna go for it, but I might be disappointed if there's an error. There could be a mistake somewhere. Something small that I didn't notice. Oh, got it. Okay, very good. 29 milliseconds isn't terrible, actually. 29 milliseconds isn't the worst. I was expecting it to be a lot slower. That actually works fine. That's interesting. Yeah, I mean, you know, of course. All right, I think I'm gonna submit it 5 times, then I won't move on. What I'm gonna do is I'm just gonna take a break, and then what I'll do is I'll come back and look at the other solutions. I should look at the other solutions for the other question too. That I didn't look at that. I should have. 1, 2. Let's do it. A few more. 3. Can't see below here. Too zoomed in. Too much zoom. Yeah, they don't have like a thing here to scroll up and down. So when I zoom in too much, I can't see it. I like to zoom in though, so people can see my code, can see what I'm doing. 1, 2, 3. Let's submit it 2 more times. Yeah, it's definitely a slow solution for sure. Let's do one more. I'm sure there's a better solution than this. This is not the fastest. It's pretty good on memory, which is interesting. Wasn't expecting that, but yeah, I'm sure there's a faster way to do this. It doesn't require a cubic time algorithm, but I don't know it offhand. I have to think about it for a while. And this is good enough, you know. It's like you don't have to overdo it. But it's definitely not the most efficient, that's for sure. It's definitely a better way to do this. It's like, oh jeez. You know, I don't know what to say about this. Binary search didn't work. Linear search was fine though. Linear search was fast enough. It's got to be a way that's better than this though. It's got to be something. Interesting that it goes pretty quick because I think it fails kind of early on these if statements. So I think it's good on most test cases too. I was wondering, because 33 milliseconds seems really fast. Like 30 milliseconds seems like it's faster than it should be. Yeah, the way this is programmed, I feel like it should be. Oh, that's because it terminates early at these points. I think that's why. It goes through some of the cases. It just goes through them very quickly. There's probably a way to optimize this, I'm sure. I don't really know. what that would be, though. Fastest way to optimize this. I don't know. Hmm. I don't know, man. I don't. How can I do this faster? I'm sure there's a way to do this faster. I'm sure there's a way of doing cubic time, quadratic time rather than cubic time. I have to think about it for a while. I could look at the solutions to see it though. I don't know. I don't know. Maybe sliding window with an actual window. Maybe it's sliding window. No, I don't think so. I can't think of an easier way to do this. Actually, I don't know. There's got to be a better way. It's got to be a better way. So we got it. It's just it took a really long time. These questions are taking me a really long time. I wanted to get through them in like a few minutes each, but they're kind of tough. I don't know what to say. There's challenging questions. I get stuck on them, I guess. And I try all kinds of stuff. This is maybe one of the questions where it wasn't really. Oh, it wasn't such a hard question as much as it was. I just kind of got confused, and then fell asleep, and then got confused. Tried to solve a slightly not a harder question, but a different question, and then fell asleep in the middle of that. Came back, coded it. Took a long time to code it, and then realized that was wrong. And then adapted that solution to something that does work. It solves the test cases in the allotted time, but it's not the most efficient, I'm sure. I think it's not the most efficient. I think you could do this in faster than cubic time. I think that's pretty slow, probably pretty slow. The question itself just seems like it's not that hard. I don't know. Maybe I'm wrong, but I don't think so. I don't think so. Yeah. So, excuse me. I could definitely replace the I don't actually need 4 of these loops. I could actually just use 2 of them. I could just do left to right and top to bottom. Left to right, top to bottom, and then top to bottom, left to right. I only need 2 directions because I could have just used
once I have a particular point and I know how far I want to go in a certain direction, then I can go over in that direction. And like, in other words, if I have a point and I'm like, okay, or a position, and I want to say, all right, I want to check if there's a box of length 3, right, 3 by 3 by 3, 3 by 3 by 3 by 3, or a square of size 3. What I can do is just move within the same matrix. I can go down 3. Well, first I could check, can I go down 3, right? In the other matrix, right? So this first matrix tells me, yeah, I can go 3 to the right. Then the next matrix would have 3 down, right? If it doesn't have 3 down, I could stop there. But if it does, then I can also check moving 3 to the right. Also check, can that spot after I move to the right 3, can that go 3 down? So the other matrix can give me both of those checks. And then if that's true, then I can also get from the initial position 3 down and check if that spot, which moving 3 down, if that can go over 3 as well. So I guess I would get the top half and the bottom half from one matrix, and the left half and the right half from the other matrix. I guess is what I'm trying to say. That could be done actually pretty easily. I could have just done that for the other, instead of going through all that extra effort of like, oh yeah, I'm gonna have 4 directional like dynamic programming matrix things going on. I could have just done 2, and then it would have just been 1 copy paste and some switching of some variables, and that would have been pretty straightforward. Yeah, that would have worked. I don't know why I didn't think of it, but whatever. I didn't do it that way, but I could have done it that way. That would have been a lot less coding and a lot simpler code and a lot easier, less memory and all of that. It would have been a lot of things better. Cool. I'll do that next time. But also, how do I... The problem with trying to figure out the box from just one of those matrices is that I have to go left to right through like the sizes of the potential sizes of the length of the box, I guess. And I was thinking maybe I could binary search on that, but you really can't, because it doesn't work like that. It doesn't work like that. Yeah, so I don't know. Hmm. Don't know. Do not know. as I move across that diagonal, you know, I'm not too sure. I don't know. Don't know. I really want a binary search. Somehow. Somehow binary search. Shoot. Shoot. I feel like I should be able to do this in quadratic time. Just seems like you should be able to. I don't know. I don't know what to say here. It's like, come on. Somehow. It's got to be doable. If I just wanted the largest rectangle of zeros or largest rectangle of ones, there's an approach that uses a stack. To find the largest rectangle of a histogram. It's pretty good. Using stack-based solution. Just apply that to just treat each row as a histogram. I think I could do it with I think I can adapt that solution to this problem. I think so. Yeah, because what I would want to check now is when I'm looking for the largest rectangle, I just also check. I just have to check that I think I can do this in quadratic time. Yes, I think I can adapt that solution. So what you would do is you'd perform the calculation that I had before, where so you have two matrices, the histogram going up, right, with ones going up, and then also the sort of histogram turned on its side, where you've got from left to right or actually right to left is probably the way to go. Maybe right to left is the way to go. One or the other. I don't know if it matters that much, quite frankly. But actually, it doesn't matter. No, it doesn't matter. Left to right's fine. Left to right's fine. So you do left to right. The sort of histogram turn on its side, so each position knows how far to the right it can go in terms of ones. Then what you're going to do is when you're performing this rectangle check, which involves like popping indices and taking a look at what's on the top of the stack and all of that, what's going to happen is actually no, I don't think that works. Never mind. Maybe that doesn't work. I was going to say you could just verify a particular rectangle by checking the length of ones. But actually, there's a few problems with that. Number one, that doesn't give me a square. And number two, I think I could end up missing stuff that way. Because even though you have a sequence of ones that extends very far upwards, the square might be smaller. Actually, I don't think that matters. Okay. This is a tricky question, I gotta say. It's a tough question. Well, to do it in quadratic time is kind of tough. Yeah, I don't see it. I don't see how I could do it in quadratic time if it can be done. I don't see it. It's gotta be a way to do it though. I mean, if you can do the other questions in quadratic time, then this should be able to do this in quadratic time too. The rectangle of all zeros, a rectangle of all ones. There should be a way to do basically the same thing, except the inner part could be empty. Could be anything, zeros or ones. Yeah, there's got to be a way to do this that I'm just not seeing. Excuse me. Maybe I could use a disjoint set data structure. I don't know about that. Okay, that might work. I think I could do it in quadratic time using a disjoint set data structure. So what I'm going to do is I'm going to combine. I'm going to get that information that I described before, which gives me the histogram, the number of ones to the right, number of ones down from each position, right? So two different matrices with two different DPs that give me that information. That's could be done in quadratic time relatively easily. And then the next thing to do is to actually take the sequences going top down and use a disjoint set data structure to combine those into single columns, right? So each column will be its own kind of identity, have its own identity, and then we're going to combine them left to right now as rows of ones start combining those columns together. And what's going to happen is when a row combines itself with a column and then combines itself with another column, the question is, question is the column that is combining with, has it already been combined? Yeah, that's the question. If you try to add an element that's already been added, it's kind of like a cycle in a graph, and that creates an event where now I can perform the square check on that event, right? And all of the possible squares should cause that event to occur. Yes. Okay. And a previous event. So yeah, basically when I go left to right and I reach another row, another column that I've already been combined with, that should create an event to trigger to a search for a square. Now the size of the square, that's a good question. So I guess I could basically mark each. I could just mark each. There's some questions there, actually. So one issue is like, well, how do I know what length of the box I should try to use, the length of the square I should try to use? How do I even remember that? How do I know what that is? I could just take the previous column that I reached and just hold on to that. And just mark, after the first iteration, all the nodes that were processed, just mark those as part of a column, and then I could just, when I reach those, I could just demarcate, this was the previous column. But actually, it can get more complicated because it's not necessarily the previous column that's of interest. Could be further back, actually. Yeah, because a row can span a whole bunch of different columns. And combine with each of those columns, right? It could be part of a larger structure of ones that are all connected to each other, more complicated structure. I could even have more than one box in it, potentially. I suppose that could be true. Could be attached to more than one point. Well, the box check takes constant time, so it's not like I can't just check the box at every event when I reach. Forget even when I'm combining with new columns, like just every time I pass a column. Oh yeah, every time I pass a position that's marked as another column. Yeah, how far back do I go though is the question. It's a good question. You know, I'm not too sure. Sorry, I'm thinking about something fun. Sorry, I'm thinking about something funny. I don't want to share it here. It just, I gotta. This is tough, man. This is like, huh? I don't know. No, I don't. I take back what I said. I don't know if I could do this with the disjoint set data structure. I don't think that's true. If you could, it's not obvious. Gee, I don't know. I don't know. I probably should take a break here, though. That's probably not a bad idea. Quadratic time, huh? That's a tough one. That is definitely a tough one. Okay. Sorry, I gotta like, trying to focus. Sorry, trying to focus. What was it? It was, yeah, when I cross a column. Right. Oh, I can binary search that. Yes. Can I? Can I binary search over distances that are already combined? Something like that. Does that work? Does that make sense? Column distances that are already connected. Yes, that actually can work. Because the disjoint set data structure, when I combine columns, the set can be basically transferred to one element. Yeah, the sets can be combined and then pushed upwards. Sets of distances from right to left. Yeah, I don't know about that. I mean, maybe. This is tough, man. I don't know. I'm definitely struggling here to see it, how it could work. Maybe I just need to check how long ago the two were connected. So somewhere in the history of how long ago they were connected. If in that history, and that actually could be an unordered set, doesn't have to be a sorted set, unordered set, so a hash map. If in that history, I find that the distance to connect now is present in how long ago it was connected. Does that make sense? I could just have the points in time when they were connected. Well, it would have to be the point in time that they were connected. The differences, there's a few different possible differences in time is the issue, right? I could keep the points in time that they were connected, but it's actually the difference that I'm looking for. And so if any of the if the difference that I see now when they actually got connected, or when they got connected again, if that difference is present anywhere, is there a way for me to check the differences efficiently? Excuse me. I don't know. I don't need to check that. Nope. I don't need to check that. I just need to check Oh, this is so confusing. This is so confusing. If the two columns are already connected, that means that I already have the three sides of the box, right? Or no, I have the top and the bottom, right? And now I just have to check that the left and the right are the same length. Interesting. Depends on the connection point. Oh, that is so confusing. I'm just thinking of like imagine like a 2x2 grid type of a thing, but instead of a 2x2, like the inner parts are like four. They're 2x2s themselves, so it's more like a let's see, 1, 2, 3, 4, 5, 6, 7. It's like a 7x7, where you've got 3 equally spaced columns and 3 equally spaced rows, and so they end up connecting, and there's like 1, 2, 3, 4, 5, like 5 different incident points, right? Where these rows and columns intersect with each other. And yeah, you end up kind of like with a cross type of looking thing. The reason I'm considering that situation scenario is because that's a spot where the rows and columns all connect to each other at interesting positions, such that I end up detecting. I should be able to detect the bordered squares of size 2, of length 2 rather, and then also the bordered square of length 4. Or actually, no, sorry. Bordered squares of length 3. Is it 3? I think 4. It's actually 4. Bordered squares of length 4, and then the bordered square of length. What did I say? It was 7? 1, 2, 3, 4, 5, 6. Yeah, border of length 7. Yeah. So there's size 4 subsquares, and then there's a size 7 square. And I should take the size 7 square at the end of it. But the question is like, well, how do you do that? How does that work exactly? Hmm. Sorry, I'm struggling here. This is tough. It's a tough one. Disjoint set data structure can at least help me like gather the columns and rows into unique entities and like figure out when they connect to each other. It helps with that, but it's kind of complicated. Like you, especially with the picture I just described with the cross and a 7x7 with 4x4 sub squares that are kind of neatly intersecting with each other. The problem with those is when you connect the columns, the three columns, when they connect again, right, a second time. Let's say I go top to bottom and I connect the columns with the first row, they're not connected. And the first row comes across, and now they're all connected. And the second row comes across. The problem is the first time I connect, I get the 4x4, right? That should be clear. It should be pretty easy to get the 4x4. Second time I connect, I get another 4x4, but the question is there a 7x7 there? The answer is no, but maybe it could connect the 7x7 because the third row does connect the 7x7. We see the 4x4, and then we see the 7x7, and question is, do I connect back to which column do I connect back to, right, from 3? So I'm connecting 1 to 2 and then 1 and 2 to 3. If I check 1 to 3, I'll see the 7x7, but if I check and I check the 1 to 2, I'll see another 4x4. But what if there's only a 2 to 3 and there's not actually a 1 to 3, right, or even a 1 to 2? So let's say if I delete some of the points around the picture, such that 2 to 3 is really the only connection that I should concern myself with. Yeah, it's a good question. I don't really know. I don't really know. Excuse me. Should always just be like as I'm moving left to right in the row, once I reach a column, all the other columns always get compared to that column on the right side. Does that make sense? It feels like that doesn't make sense. It feels like that's not correct. Not the way to do it. Yeah, it's not correct. No. I think I have to check every column that I pass through. I have to check every column that I pass through against the column that I just saw, the new column, which I think I have to have another form of dynamic programming of some sort, which is not obvious at all. Maybe a stack is what I need. I don't really know. Some kind of a stack solution. Hmm. You know, I don't know. I don't know. I have to really think about this for a while, I think. I have to think about this for a while. Getting kind of tired. I think I'm going to stop here, take a break. I haven't got the question. I probably should check the solutions to see if there's a quadratic time. I'm sure I'm almost certain there's a quadratic time solution. There's got to be. There's got to be a quadratic time solution. It's pretty, I would be surprised if there isn't, but it's definitely not obvious how to do that. I'm thinking maybe a disjoint set data structure. I'm thinking maybe, maybe a, what's another one? Disjoint set data structure, maybe. Maybe there's some other way of doing it. Maybe I could use a breadth first search. I think that might help too. You know what? Actually, disjoint set data structure might be the way to go. Or I don't know. I'm thinking of like when I want to use maybe like a level order traversal, and when I can combine elements together, right? And maybe I just have to write in like when I visited a particular element. And that creates like an enclosing. And I'm looking for like the largest enclosures, something like that. Something like that. I don't know. I don't know. Struggling. I'm struggling to see some kind of like a disjoint set data structure, some kind of breadth first search, some kind of level order traversal, something like that. I think could work. I'm thinking it's got to be something like that. Because each of these borders basically is a cycle, right? It's just a very specifically structured cycle. So there's a kind of cycle detection you could do, I think. Something like that. Something like that. But it's a little more involved, right? Special. It's more than just cycle detection. It's like a little more complicated than that. Trying to think here. Trying to think. I don't know. I should take a break. It'd be good to take a break. I don't know if I'm going to come back to this. It's definitely a part 2. This one is part 2, but the part 3 or another to revisit this. I could revisit this and look at the solutions as part of and just kind of analyze the solutions. It's maybe not a bad idea because this was kind of a slow solution that I came up with here. This was a bit slow, you know. Correct, but slow. Cubic time, in fact. Not the best. Not the best. Really could have some improvement. That's the thing, is when you're interviewing, they're going to ask you stuff that like they want
usually they want like the optimal or like very close to the optimal solution. This is probably not optimal. Probably not actually a passing grade, so to speak. Yeah, it's a bit rough. It's a bit rough, I'd say. All right, with that in mind, I'm going to go ahead and take a break. I don't know. I probably should read the solutions. Is probably what I should do. I'll come back on later and probably revisit, not revisit it, but just look at the solutions or something. I don't know about this one. I'm going to take a break though. I'm going to do that. Maybe ponder it off screen for a while. Off stream, yeah, off stream. So thanks for watching. If you liked the video, give it a like and subscribe for more videos like this. This is a challenging one. I think this is really hard to do. Not hard. It's on the harder side to do in quadratic time. To do it in cubic time, it's not too bad. You just saw that how I did it, and that could have been improved quite a bit. Actually, the solution was not the best. All right.